So in this video we're going to show how I went through the house and wired up a bunch of receptacles and how I approach it and the logic that I use. But we started this project, all we were going to do, Jimmy asked me, hey, can you take a look at this receptacle and just tighten it up? It's feeding my heater and it was moving in and out. We took this apart, we realized it doesn't have a ground, so then we had to put a new outlet in there and feed it. Since we were doing that one, we wanted to put outlets on either side of the bed. We figured as long as we're in the crawl space underneath, might as well take care of those outlets. And then as we're walking here, there was an outlet existing in the house that was up at this height, which didn't make any sense, and it didn't have a ground. So we lowered it down to here and rewired this from the basement. Since we're working on this side of the wall, we figured why not put one on the other side of the wall. So we came in here. This room really didn't have any outlets. There was like one outlet in here and everything was on extension cords. And so we rewired that one. And then since all of the devices, there was a plug strip in here and the computer and everything was plugged into that. So I decided to give this its own quad in the back there. Then we looked around the room, we said, as long as we're in here, let's go ahead and finish this up.
So it's all supposed to be one outlet.
Right, so we added a receptacle there for those machines, a receptacle here for this sewing machine. We might eventually add a light switch and a sconce, we'll decide on that later. And then since we were working on that side of the wall, we added another receptacle here.
And then the last one is the one in the foyer there.
Yeah, can we go through?
Yeah, go through.
And then the last one we decided to add was in this central corridor just because it's a convenient location. And we were already working in this wall here on the other side of the wall. So in the basement, we know this is a common wall. It's easy enough once you know where the wall is to just drill up and add. So all in all, I think we added about a dozen outlets and then a couple in the basement as well.
Yeah.
All from that one shaky outlet there. But this is how the job progresses and the house needs it. So it was a fun project to work on. All right, we're just going to do a simple outlet change here. The reason we're changing it is it doesn't look secure and it doesn't feel secure. It's bouncing around in here. First thing we're going to do is remove it, take a look at the wiring, and then take a look at the box. If we have a solid box and the wiring's in decent shape, then we're just going to put a new receptacle in there. So most of the times when you're working with old outlets, these screws are typically painted over. So this one's not bad, but sometimes they're painted completely round. So I just get my screwdriver in there sideways. You can use, this is a really nice screwdriver to have, a little trim driver. But I get that in there and I hold it on an angle. Alright, so we re-energized the circuit, and the reason we did that is to make sure before we connect this receptacle that we have a ground. And the way you do that is just test it from the hot leg. Well, if you test it here, you get 120 volts. Now you should get the same thing when you're going from the hot leg to touch the box. And unfortunately you don't get anything. Another test would be continuity. So if you ring the neutral to the ground, you should get continuity. You should get that. And we're not getting anything. So now we have to fix the ground.
Quick $10, I'll get this. Be out of here in 5 minutes.
I can't tell you how I'm laughing because I can't tell you how many times that happened to me.
Something's fucking. I was working with my friend Tommy doing that. Gave Eddie a job. You know, it's a freebie job. This was before Shark Price. Don't worry about it. Pesky insulation. Get in her way.
So we were lucky enough to find slack on the Romex inside, and we know that there is a ground in it. So now what we're going to do is cut the jacket open and insert it into the box and give it a test and see if the ground is in good shape. And this is another example of just because something works doesn't mean it's right and doesn't mean it's safe. This could have been safe. I'll say it over and over again, but the ground is the most important connection in any kind of splice or any termination. The ground is what keeps things safe. The ground is what keeps people from getting electrocuted and keeps people from outlet's catching fire. Because if there is any issue with the outlet, the ground will allow it to trip. It'll trip the breaker, and it lets you know that you have a problem. So with that being said, if a breaker trips, don't just go reset it. You have to do a little investigative work and find out what made it trip before you reset the breaker. If it's just something that was overloaded, you had too many things plugged in to that outlet, you had a heater, you had a hair dryer, and that's what made it trip, now you know you just unplug those and then you can safely reset it. But if a breaker trips and you don't understand why, do not reset the breaker, because all you're doing is putting the problem back in the wall. If you don't know how to handle it, you call an electrician, they come and they'll figure it out for you. Here we are back in Jimmy's bedroom, and I went to fix this outlet, which was kind of falling out of the wall, so I went to just re-secure it, make it safe. When I took it apart, I realized there was no ground coming into the box. So we opened it up, we got into the Romex, we did find the ground, but then when we went to test it, the ground doesn't go back to the panel. So we can't find it in the house, we don't know where it is, it's not worth the effort. And since we have a Crawlspace underneath this floor, there's a nightstand that goes here and a nightstand that goes there, and we want to put a receptacle underneath each one. So while we're running the wire for this one, we're going to run that on a direct line into the basement, and then we're going to daisy chain these two and run that into the basement.
So there'll be a circuit for this too, and then that one alone.
Correct. And then the circuit that feeds these two, because these are going to be light draw circuits, I'm going to put these on with another set of circuits somewhere in the house. Just a couple of general purpose circuits, like this one right here. We know right here this doesn't have a ground on it. So this is another one that I want to get into and fix that. We'll fix that through the basement as well. I put that on with these two. But this one I'm going to leave on its own circuit breaker, because you're either going to be plugging in a heater at this location or an air conditioner.
Right.
So either way, I want that to be a dedicated circuit. 18's a good height. Might be a little too cool. I'll put about 16. What about here? So now what we're going to do, this is the area that we know we're going to put a receptacle here. So we're hoping that there's no studs in the back. But what we're going to do is just shoot for it. Because the door frame is here, most likely the nearest stud is about here. And then I don't have a stud finder with me right now, but just knocking on the wall, I can hear it's hollow. And then it starts getting solid around here. So I'm pretty sure we're going to have a hollow in this location. And then we're looking at, there's a side table that goes in this location. We mounted it, drew a little line on it. That's the bottom of that. So then we're determining what's going to be the most convenient place to put this, what's the most convenient height to put it. So we're going to go right about here. So now I'm laying out the box at the ideal location. I'd like to be dead center of that nightstand if I can. If there was a stud in the way, I could shift it over an inch or two, because it's not that critical. But we are cutting it. As I'm cutting it, I'm reaching in to see where the stud is to make sure I can stay in that location. This is just sheetrock. There's no plaster back there, so it's going pretty quickly. And now what I'm going to do, now that I have the hole, now I'm going to use the pipes that are coming through the floor as a reference. Measure over, see how far back the wall is. It's 2 inches to the wall. It's another 2 inches to the center of that wall cavity, and then about 6 inches over. So now I'm getting ready to go down into the crawl space, giving a little shout to the ghosts, because it's a 200-year-old house. I set up a bright light for myself and put a knee pad down there so I can work comfortably. And now I'm going to check my measurements and look for my reference points. Alright, well anyway, the other side of this is the basement. So that's easy. And then right here are the two pipes that we just measured off of to find the wall cavity. There's 6 inches to the right and 4 inches back. So I'm going to drill up right there, and hopefully we get right up in the wall cavity. So I got to get the drill and the auger bit now. The barn from here.
Really?
Yeah. I'm seeing the lights on in the barn. I'm like, what am I seeing lights over there?
Uh-oh. It's only about 500 feet away. Maybe I need a little caulking. All right, so we drilled the holes from underneath, and I ran the wire up into the walls. So now I'm cutting a hole in a new location. This is the one that's going to feed the heater or an air conditioner. But since we added the two under the nightstand at about 15 inches, we decided to put this one also at 15 inches. And this is the one that's underneath the nightstand on the right. I'm just showing how I typically would install a box. And here you can see the wings that support the box. So you tighten those up and that pulls against the sheetrock in the back, and then the flange on the front of the box keeps the box from moving backwards, so it makes a nice tight connection. One thing I started doing on this job was to widen the gap on the sheetrock on either side of the box, and then I'll fill that with caulking later on. And here I'm showing how I pre-shape my wires and cutting them to size. Now I'm skinning them with my pliers, and I'm struggling a little bit there because the pliers are a little dull. So I break out my skinners after this and I start using the skinners. This is the other location with two wires going into it, but now I'm going to splice these together and then tail off for this receptacle.
When you say tail off, you're going to use those two, you're going to put another one on there.
Yes.
So tail off means 2 to 1.
It means the receptacle has its own set of wires and it goes under a wire nut to the other circuit.
So you're saying there's going to be a tail on that receptacle there?
Yeah.
And then so you're going to have 3 under a wire nut on each one of those?
Correct. So that all the
okay.
amperage that goes in the circuit is traveling underneath the wire nut, not going through the screws on each side of the receptacle.
Oh, makes sense. I see that now. Oh, it's funny. I watched you do it. I didn't even see you do it.
And here I'm putting the tape on, but I'm placing it. You don't stretch the tape, you just let it lay into place. Press it on, and that keeps it from falling off. And twist the wires together. You don't go too hard on the copper because you'll weaken it. So you just lay it right in there, give it a clip, and then the wire nut is going to do a lot of the work for you.
What size wire nut is that for 3 pieces of wire?
That's called, they call them red yellows for obvious reasons, but 3M makes them, and it has the range of the old yellow wire nuts and the red wire nuts. It can do, a couple of smaller wires or up to
No
3 or
kidding.
4.
I had no idea. I was wondering why I'd seen wire nuts with 2 colors now.
Mm-hmm.
Just harkens back to the original system.
Yeah. The same thing with the blue and the orange that you have out there.
Yeah, I had
The
no
blues
idea.
were smaller, then the orange, then the yellow, then the red.
Yeah.
Now you can see the caulking that I add to the side of the box. I cut the sheetrock a little bit just to give that caulking a place to go, and then it really locks the box into the sheetrock. And it keeps the box from moving and makes it all a nice tight connection, plus it keeps the air drafts from traveling from behind the box. Here I'm putting on the plate. I don't like the way the plate's sitting, so I put a little caulking behind the plate. So when the caulking hardens, it's a nice solid connection on the plate. The plate won't wobble on the wall.
Nice.
All right, so here's our brand new sub panel that we installed over a year ago, almost 2 years ago. We haven't tapped into it yet, but this was going to be, we put this in the basement so that we can tie up we had a lot of extension cords running down here.
What I wanted to show here was how I get the wires across the basement, and what I look for is the clearest path where it's above all the other wires and it's going to lay nice and neat. I'm shaping the wires out. Now I'm going to mount the box. I decided where I'm going to put the box, how I'm going to enter the cable into the box to make it easier to splice and to keep the circuits separate. In this box I have 2 separate circuits, so I'm lining up the connectors so that the wires right across from each other will splice together.
Tell me a little bit about those black connectors. What do those do?
So we call those buttons or black buttons. It's made for the Romex, so that basically what it is it strain relief. It keeps the wire from pulling out, but it also keeps the sharp edges of the box away from the jacket of the Romex.
So it's a one-way push-in.
Yep.
You can't pull it back out without
Right.
pry it open.
Exactly. You'd have to kind of cut it apart to get it out. And you can actually get 2 Romexes into one black button if you want.
Interesting.
Now I'm just showing how I splice the wires. There was 2 separate circuits traveling on the cables coming in from the right, and they're just going to splice straight across to the other ones. And what I show at one location is how the box has a ground on it also, but I'm only tying the box ground into one of the circuits. It doesn't matter which one I pick up, but I'm keeping my grounds separate because they're separate circuits. And then the box ground just gets tied into either one of those.
Not both.
Not both, because then you're combining grounds and it can be a little confusing.
So you have these two wires coming in from the right, and then when they leave the left side of the box, they go to two separate circuits. One is under the nightstands, and the other one is under the window.
Correct. One's a direct circuit that's not going to get anything else spliced into it, and the other one I'm going to tie a couple of other circuits, or rather receptacles into.
Yep. Into this box, or will we add another box?
I'll probably extend this feed to the other side of the basement,
Right.
and then tie those circuits in over there because they're in a different location.
All right. The other one's in the other room.
Mm-hmm.
What are we looking at there? Anything specific?
Well, there you can see the box ground in the back is only tied into the circuit on the right.
Right.
I'm showing how I keep those separate. Then I like to pack the wires nice and neat and logical so that the next person who looks at this can make sense of what I did, and then I label the jacket as well if I can. I like to just say you leave a clue. You always leave a clue for the next person.
You laid those wires in, turned one direction, and then obviously turned the other direction, indicating they're separate.
Yeah.
Very nice.
See how that makes sense to you just by looking at it.
Yep.
And then once it's buttoned up, then I put the staples in, but the staples you want to keep, they're just to hold the wire up. They're not to nail them. You don't want to pinch the wire. So I'm very careful when I'm putting the staples in. You just hit them enough to hold the wire in place, but the wire should move a little bit underneath that staple.
Interesting.
Just so you don't want to pinch it. And then I route the wires up above any hot pipes. I want to explain a little bit about these arc flash breakers. They're required everywhere in a house now by the National Electric Code. And this is the neutral that's going out to the field or out to the location. This terminates right to the breaker in a space that's called load neutral. And then what I'm pointing out there is the neutral that gets built into the breaker. That's what terminates to the panel neutral strip. So the neutral lands on the breaker in the spot that calls out for the neutral, and then the hot wire lands on the hot wire. It says line. And then the ground terminates to the ground bar. What I'm showing here is how I remove the painted on plates. I just scratch it around the plate, and then I usually give it a little tap, and it frees it up from the receptacle. They're usually painted solid. And then if it's stuck, just razor knife it out. Now
What's going on in there? Is that paper? What is that?
Yeah, that's some old wallpaper that's in there.
Oh.
You're looking at a bit of a time capsule. So now this is the location for the new box, and because it's old plaster, it kind of fell apart a little bit, but that's fine. I actually slip a block of wood back in there to tie the lath together. I want to make a nice connection because when I replaster this, I want it to be solid and not have things that are moving around back there.
Yeah.
So I got my two wires coming in from the basement. And then since I'm working on that side of the wall, I'm going to add the circuit to the other side of the wall. And I'm showing that's an existing box, but what it didn't have was a good ground, so I put a self-tapping screw to the back of the box and tie the ground in there. And then what I'm also showing with this box is that I pre-shape my wires so that when I put the receptacle on, there's a little black button in the back. You can see that. I use that for a strain relief. And my wires are shaped into the location that they're going to land on the receptacle. And the wires are turned in the same direction that the screws are going to be tightening up. Getting ready to tie these in. Go to land that ground on these other grounds. And if the other grounds are twisted too tight, all you do is grab your pliers and backspin it, and then you can lay your new wire into that and then tighten it back up again. So today we're going to add a couple more outlets. We're going to put one on that wall, and as long as we're putting one on that wall, there's one existing, but we're going to rewire that just so we know that everything is brand new wiring. And since we're putting one there, we're going to put one on the opposite wall there.
All this space is available underneath in the basement. It's accessible. And just looking at a glance, I see that going through the wall, through the floor, and realize that I should be able to see that in the basement as a reference point. So I can measure over this way for that, and then this way, and find that area. And chances are I should have, because the electrical panel is in the basement, the feed for that outlet right here should be in the basement, and we should be able to see that downstairs. And then we're going to put an outlet on that wall. And since we're working on this wall, we should be able to find this in the basement easy enough, this whole wall. And since we are working on this wall, we're going to put another outlet right there. And that's today's project. So this is that location that has where that wire mold was going up the wall. There's a piece of Romex that goes into it. So I have that as my reference point now. And this area upstairs is the doorway. This area right here would be that wall with the door opening is right there. And then this is where I'm working, in this wall right here. And there's two pieces of BX going up, so either one or both of those is going into my outlet box. And then a little further over, this is going to be that other wall. Not sure where exactly it falls out, but it's going to be here somewhere that I'm going to do the other bit of work in here. These are my two BXs coming up. I think and I hope that these are both coming up from the basement. In order to check which one is the hot leg, you can just about make out that these are the black legs, so these will be the hot legs, and these are the white ones. But the wires are so old, a lot of times you don't see the paint on them, so they all look like black wires. So one way to test it, if you do have a ground, is to go to ground, and you can see that's the 120. And if you test the other side, you get continuity, because in the panel the ground and the neutral are connected. I cut the box out and I had to do a recon on this thing to see what I'm working with. And what I find is this is one coming up from the basement, and this goes upstairs. So this has to be refed. The easiest way to do that, because we got to get to the wall, I got to put a metal box back in. I'm going to put a gem box back in at the height that I want. So here I'm measuring over to the studs so I can figure out where I can mount this new box. I got plenty of room to put it in to the right. As far as the gem boxes go, the only thing I had on hand was these boxes that I had demoed from the World Trade Center. So what I'm showing here is how I can take those three, remove the screws, and change that into a single gang. And now I'm opening up the wall as carefully as I can for the new location, where the new gem box is going to go.
Gem boxes means metal and not plastic?
Yes, that's the metal box that usually goes in old work. And now I'm skinning back the existing BX that's in the house. The BX that goes up through the house is only 14 gauge wire, which is only good for 15 amps, which is on a 15 amp breaker right now. The BX that I had pulled out is the feed, and it's actually the feed coming right from the panel. So instead of taking the power from the other circuit that I ran, that's going to be on a 20 amp breaker, because there's nothing else on this right now, I'm just going to use a box. I'm going to pick up the BX ground with a metal box, and then I'm going to take this receptacle and I'll cut this back and I'll put these two tails into this box, so that those two outlets that I added today will be tapped off of that same room that it was on, and it'll be on 15 amp breaker. That was the concern that I had, was the wire gauge going up was too small for 20 amp breaker. It's not safe.
So you're going to keep it all
on a 15 amp breaker. Yeah, so I was going to put it on its own circuit, but I realized this is already on a 15 amp breaker. It's on its own circuit.
Right.
So I'm just going to pick these up right now, and now I know I could probably tap a few more off of this if I want.
So now this is the, what is this now? This is the hallway?
Now this is just a jumper going over to the other box. So I am going to put a box here, and I'm going to add a few more receptacles. That's going to be on my 20 amp line. But now I know all the wire that's on that 20 amp breaker is 12 gauge, and it's rated for 20 amps.
Right. So because of that one that goes upstairs, you're limited.
That's right. I have to keep it on a 15 amp breaker. So that's why I'm going to reuse the existing feed that's already in the panel, and it's already on a 15 amp breaker.
Right.
So that's why we're using this.
Okay.
That's it.
All right, so tell me what you're doing here. What is this?
So this is the box that I'm adding to pick up the BX ground, adding a ground tail to the back of it, and now I'm putting in a good connector, getting an idea how I want to shape my wires. So 2 of those holes are going to have the black buttons in them, and then the one that's picking up the BX is going to have a connector, a clamp style connector. That's what I'm installing now. And you'll see I tighten that up with my pliers to get a good connection on that. And then I'm going to put the BX in there and get a good connection with the clamp, and that's what's going to guarantee my ground throughout the house.
Now, is there ground running through the jacket of that, or is there a separate ground?
The old BX, the ground,
Is
the jacket of the cable is the ground. And
that's why you can't forego it. You have to keep going with it.
that's correct. Yeah, it wouldn't be safe without that ground. I'm tightening it up. I'll snug that up later on with my pliers. But right now I'm going to get it to lay up nice on that beam and look good.
So I'm looking at it now. The ground comes into the BX on the external casing, goes to the box, and now you're going to jump it back into the Romex through that pigtail you added.
That's right, yeah, because the ground is existing now on the box, and then the tail is what's going to pick up the ground and connect it to my Romex.
Right.
Now I'm just shaping the wires so that they look nice. And again, when I staple that off, I'm just going to basically float the Romex underneath my staples.
What is the difference between, obviously, the old construction is a lot of metal jacketed, that's called BX, and the Romex is the yellow stuff. What is the difference? Is the yellow stuff okay now? And like I'm saying, do we have to worry about rodents or anything like that?
Well, the Romex is fine to use in the house where you can, in the basement, you can see it. So if there is any damage to it, it would be visual. You can repair it. And then when it goes up on the wall, inside the walls, we don't really have to worry about it too much. The BX cable actually, from what I understand, it used to be called Bronx cable, and BX meaning the Bronx, New York, and it was to prevent it from rats chewing on the cable.
Right.
So that was the original idea behind it.
Considering I live here full time, I wouldn't really have to be too worried about it. So I would hear them chewing.
Right. In the basement, it's safe. Like in the barn, you notice like we put MC cable, which is the metal jacketed cable, all throughout the barn because we know there's going to be rodents out there.
So this is all your hot leads coming together right now?
Yes. And what I always show on my splices is the grounds get spliced first, then the neutrals, then the hots. And I typically leave my hot wire out on the top when I shape it.
Oh, nice.
Because that's the first thing you can access. And then just lightly staple it to the beams. So I'm just going to bring you up to speed on this. I decided to add another receptacle between this location right there. So it's between the legs of this desk. And when I went to put this in order to get a reference, I went downstairs and I measured over from this last receptacle over here. And then when I went down to the basement, I saw a copper pipe coming up in the area that I wanted to drill, and there's the pipe right there. So I stuck something down the hole just to confirm, and then measured over. Now I can get a hard measurement exactly where I want to be. And I drilled up in the basement to see, because I didn't know where I was going to be able to clear first. So when I drilled up, I thought I hit wood, so I did an inspection hole and found out I have a double 2x4 in here in the wall. So I moved over 6 inches and cut another hole, and then was able to measure back and see where the stud is. And now I know from the hole that I did in the basement that I'd have to be at least 3 inches over to clear this stud right here. So this is the location where I was talking about. I drilled it originally, and then I went up and there was a stud here and a stud here, so that's no good. So I had to shift to the right, but I had this beam in my way. Thankfully it's mortised back, or has a tenon rather. And then I was able to just get my drill up in here and then drill up in an angle, and I got into that hollow in the wall and was able to mount the 2-gang box up in there.
Unbelievable. I can't believe you were able to work the wonders you were able to with a drill bit.
Yeah, and the drill bit wasn't that long.
It's crazy.
But it was just enough to get up in there on that angle. And
amazing.
The house has been good. It's been working with me. It wants me to wire up some outlets in here, so it's been letting me get up in its walls. So now I was going to put a junction box up in the ceiling and tie my receptacles into that, but I decided to mount it on one of the columns and put a quad receptacle on the face of the box, adding another place to plug in down in the basement. We have plenty of room on the circuit to add receptacles, and now this gives Jimmy 2 locations in the basement. Convenient. I mounted it at a height that I want to see it at. I saw no reason putting it down low. Now you can find the outlet very easily. And now at this point I zoom in, I want to show actually how I splice. So the first thing, I break my wires out and I get to my grounds. My grounds always get spliced first. And I just shape them out, tightening up the tail in the back. That's actually the feed cable coming in. I ground that to the back of the box and then I shape it. Rather than using a tail, I'm using the feed wire as the tail. I'm just showing here how you don't tighten up that splice too much. And I'm going to splice 4 wires together. Now the neutrals get spliced after the grounds. I shape them all the same length. And what I want to show here is if I'm going to splice 4 wires together, I'll just take 3. I splice 3 of them together because they twist nice. And then I'll just lay the 4th wire into that group of 3. I don't over tighten it. It lays right into the grooves. Give it one little snug. And now the blacks get shaped. And you can see I just go up. They're the length of my hand, and then I stick my thumb out, and that's where I cut it. And I'll do the same thing now with the blacks. I'll put 3 of them together just because it's easier this way. Add the 4th. And the reason I didn't cut them is because I'm going to be adding the receptacles now. And the grounds just lay into the existing grooves. And because there's so many wires now, there's 4 wires in there plus the 2 for my tail. When I go to put the wire nut on, it puts a little resistance up, so then I just use my pliers to tighten that wire nut down. And I use the white wires, same thing, always the grounds first, then the neutrals, then the hot leg. It's the same thing when you're taking the circuit apart. You start with the hot leg, then the neutrals, then the ground. You do it in reverse order. And the reason for that is if in case the circuit gets energized while you're working on it, that's the safest way to handle it.
Those wire nuts, how big a lump of wire can they handle?
That would be the max right there. So 6 wires would be...
No, 6 wires is 12 gauge.
6 12 wires. Yeah. But it comfortably handles that many wires, but I wouldn't want to go any more than that. The next step up would be a gray wire nut. And then the next step above that is a blue, but so the 3M makes a gray-blue wire nut.
Right.
And we have them, but they take up quite a bit of room in the box, so I don't like to use those unless I have a large junction box to splice in. But I'm comfortable with the red yellows, and I just snug them up with my pliers.
Now, you don't put tape on the connections at all?
The wire nut, no.
There's no need to?
No, the wire nuts have an active spring inside of them, so when you tighten them up, the spring opens up, and then when you let go, the spring compresses onto the splice. Now, I appreciate my wires, and I want to make sure that that cover goes back freely without pinching any wires.
Nice.
So that's, and it should always be pleasing to the eye when you're done. And here I'm just putting the final coat spackle on the wall. I have my caulking around the box. And then just doing a quick little tune-up, some spackle.
So you're an electrician and a spackling expert.
And a carpenter, and a welder, and a tin knocker.
It's funny how much work that you put into the walls and spackling, whereas the average electrician would just do what he does and leave it to somebody else.
Well, that's the case, and I tend to work for clients that keep calling me back, so I like to leave it what I call paint ready.
Yeah.
When I leave the location, all they have to do is just touch it up with a little paint. And that still needs to be sanded a little bit in that location, but of course I'll wait till it dries and then touch it up with a little sandpaper.
Nice. Looks great. And now
And
I have
that's it.
700 more outlets than I had before. So
And they're all solid.
then I push it into the wall.
All right, you just watched me install 15 outlets in an old house. I hope it was helpful. Any questions you have, please put them in the comments below, and you can follow me on Instagram for daily tips and tricks.